Hello everyone. So this video will explain to you about chapter 2 part 1 of BMIV 1313. Okay. So in this video you need to understand two things, only two keywords. There are sinusoids and also phases. So what are sinusoids? Sinusoids are actually signals and we represent AC signal. Okay, we represent AC signal using sinusoidal. Okay, so for example, this is one example of an equation, AC signal. In this kind of equation, there are amplitude. VM here will explain to you how tall or how high, how much the height of amplitude for that signal. And also omega is actually the angular frequency of the signal. Okay, so if you write the equation, it will be look like this, but if you try to draw it, it will be something like this, drawn in this figure here. So you can see that the maximum amplitude here is Vm, and also the angular frequency, usually we don't see it directly. Okay, but how to know about that? So let's see the next one. So in this equation just now, Vm equals to, sorry, it's not Vm, it's V. Okay, it's a voltage, and this voltage has a maximum amplitude. Amplitude reading here, and then it has a signal, and then omega t. Okay, so you need to know this omega can represented by using T or F. What is T? T is actually the amount of time taken by the signal to complete one cycle. So can you take this here as one cycle? Definitely no, because at pi here, the signal has not complete one cycle, because in order to complete one cycle, you can see it repeating the cycles, right? So you need to understand that one cycle of this signal is actually ends here, and your t or your period counted from here to here. Okay, so this is t. So in order to calculate the frequency of the signal, you need to reciprocal of that t, 1 over t. And also, you need to know that omega can be calculated using 2 pi f. So whenever you want to find f, you can rearrange. You can, if you have omega, you want to find f, you can rearrange to find frequency. For example, in this case, you can find frequency by using this calculation here, right? So for example, in this figure here, there are two signals, right? VT and, sorry, V1, and also, is that V1? Yes, I guess so. Or is it VT? VT and also V2. So VT is the solid line here, and V2 is actually the dotted lines, okay? The graph or the waveform with the dotted lines. So you can see, you need to determine which comes first. So for example, if you see this graph, this illustration, from this illustration, you may say that, V1 or VT is come first. However, you need to determine which sinusoid occurs first in time. So if you study or you examine which one occurs first in time, definitely the one with red dotted lines, right? So V2, that's why we say V2 leads V1. Okay, and this phi here is actually the difference in angle between the two. the shifts, the angle shift, we call this. The angle shift. Okay. Or you can also say that V1 lags V2 because in time, V2 occurs first, right? So you can say that V1 or VT here occurs later than V2, or V1 lags V2. So for example, you are given this question here, you need to identify the amplitude, phase, period, and frequency of the sinusoid. An AC signal, you have an amplitude, Vm sine omega t, right? Plus phi, and this is actually the angle shift. So in this case here, let me zoom a bit. In this equation here, this is the amplitude. So straight away, you know that the amplitude is 12. Okay, next, what about the phase? When the question asks the phase, this is actually the angle shift. Okay, so the phase is plus 10. Okay, you just directly take the value here. If it is minus, then it should be in minus. It should be written in minus, plus 10, plus 10 degree. And then how about the frequency? Yeah, so how to find the frequency? First, you know that this 50 is actually your omega. So omega, you know, is 2 pi f. Can you rearrange to find the frequency? Yes. Find frequency by taking omega over 2 pi. And the value of omega is 50 over 2 pi. Taking this pi is the value 3.1415. So you can calculate the value. Or you can also leave it as this one. Okay. For example, this has the same form of problem to be solved. The question gives you a sinusoid 30 sine 4 omega t minus 45. Calculate amplitude. So directly, the amplitude is 30, right? And then phase is minus 45. How about the angular frequency? 4 pi. Or you can also replace pi with 3.14, and that's how this number comes in. So that is actually will give you this value, and the unit is radian per second. It's the same. Okay, if you write it for pi, the unit is also radian per second. Okay, bear that in mind. Next is the period. If you still remember what is period, period is T actually. And how do you get your T? T comes from your frequency. And you know that from this equation here, the frequency is not that direct, isn't it? You need to identify the frequency from the given omega. So you know omega is 4 pi. Sorry. Omega is 4 pi. And you know that this 4 pi is actually equals to 2 pi f, right? So equating those two together, 4 pi or equals to 2 pi f, cancel out, simplify, you get f equals to 2 hertz. That's simple. And then when you have your frequency, you can calculate your period, isn't it? So your period is 1 over f, and that is 0.5 seconds. That will give you 500 milliseconds.